congruent. Now we got to talk about when triangles are similar, what that means. All right, two triangles are similar. First thing, corresponding angles are equal. So all the angles are equal. So if we make this, here you go, triangle ABC versus triangle DEF. And we will make A congruent to D. Reminder, how do I make two angles equal? How am I going to show you this on my diagram? That A and D are equal. How am I going to show you? Just trying to do a little midterm review too. Arc marks, right? Come on, let's act like we've been here. A congruent to D, B congruent to E, and C congruent to F. So if two triangles are similar, corresponding angles are congruent. Which is the same for congruent triangles too. This is true for two congruent triangles. Here's the difference. The sides are not equal. The sides are not equal. The sides are proportional, and here's what I mean. Let's put AB as 5, ED as 15. And then let's put, 10 for AC, and DF is 30. See what I mean by they're in proportion. 5 over 15 is the same as 10 over 30. And then the final side here, I'll put 8, and he guesses what the other side's going to have to be then. 5 to 15, 10 to 30. 8's got to match up with the side length of what then? Dig deep.
24.
Why 24?
Because it's 3 times.
5 times 3, 10 times 3, 8 times 3, 24. Okay? So you see the sides are in the same ratio. 5, and you don't have to write this down, 5 over 15 is the same fraction as 10 over 30, same fraction as 8 over 24. The sides are in the same ratio or proportions. All right. Anybody know the sign for similar? Ever seen it? You probably have, but never knew. That's the sign. I don't have anything else for you. Everyone's like, did I write that down? Does he have more? Nope, that's it. Can we call it by its mathematical term as well? It's not the squiggly. Okay, it's not the squiggly. Anybody know? Tilde? Never heard of that? Tilde? It's called a tilde. All right, tilde. All right, so if I wanted you to write that these two triangles are similar, a similarity statement, it's the same thing we did for congruent. Same thing. Make sure the sides and the angles match up. So triangle ABC. The only thing you got to watch out for, because you've been brainwashed to write what next? Congruent. So watch out for that. Similar to triangle DEF. Again, make sure the angles and the sides still match up. Just watch out. Don't put congruent, put similar. And the final thing I want to talk about is this term scale factor or similarity ratio, because we're going to hear that a lot. What's the scale factor or what's the similarity ratio? That's the ratio of two corresponding sides. So you pick two sides that match up, put their side lengths over each other. Watch and learn here. Here you go, Anna. Give me two sides that match up in each triangle. 5 and 15. So you could say the similarity ratio is 5 over 15. Is that the only one you could give me? Heck no. 6. 6 in the house? Nate, give me another two sides that match up. Okay. Or you could write the similarity scale factor is 10 to 30. Or maybe you're just a stud and you want to show off. 1 to 3 because you reduce. Okay. Any one of those are acceptable. You take two sides that match up, put them over each other. That's what's called the similarity ratio or the scale factor. All good? Questions? Two triangles are similar, angles are equal, sides are in the same ratio. All right, let's roll. Real quick before I start these notes. What's that? What are those 5?
Triangle equal.
Proving triangles equal. Congruent, right? Those are the 5 ways of proving triangles congruent. 3 ways. 3 ways of proving triangles similar. Here's the main method right here. Main method. AA, angle, angle. Angle, angle. Find 2 angles that are equal, you got triangles that are similar. Angle, angle. Angle, angle. All good? That's 2 triangles are similar if you can prove 2 pairs of angles are equal. So I have 2 triangles down here. Let's write a quick, I've missed this so much with you guys. Yeah. Write a quick 2-column proof why the triangles are similar. All right, 2-column proof. This is getting you guys ready for tomorrow. What did I already give you here? What do you already know? Which 2 angles are already equal up here? I gave you 2 already. 10, what do you already know is true? Yep, H and S, they're both 45, they're congruent. So I already gave you H and S. So if these 2 triangles are similar, you just need to give me another pair of angles. Angle, angle, that's it. Not 3 pair, I just need 2 pair. Angle, angle, where's the other pair then? Midterm review. 2, where's the other pair?
I got UOH and SOE.
Yep, don't you dare say reflexive either. No chance. That has been driving me nuts when I see the kids do that. UOH congruent to SOE because 9. What type of angles did I just were given there? Vertical angles congruent. Yep. And that's it. Hey, you're done. These proofs aren't going to be that bad this unit. They're not. Trust me. You're done. 2 pairs of angles congruent. The triangles are similar. UO8, UHO. The only thing you got to do is make sure you match up the sides. If I go UHO, I got to go ESO. Oh! Look at your paper. Anybody write down congruent? Don't be an embarrassment. No, I'm just joking. You got to get out of that mode, right? Don't write congruent. And then what am I going to write for a reason? Angle, angle. That's it. Nice, huh? I just got to find 2 pairs of angles. Who cares about the sides? So that's angle, angle. Any questions? Angle, angle? Good? What's the second reason then? I got angle, angle. Ooh, this is going to look familiar. Side, angle, side. But it's different from the side, angle, side we used to have. You need to have an angle, but the sides around it have to be in the same ratio. What do I mean by that? Take a look at my diagram here. Does everybody see the side, angle, side? All right. But you got to check if the sides are in the same ratio. So here's what I have to check here. Is 10 over 15 in the same ratio as 12 over 18? I know some of you are like, how did he know the 10 matched up with the 15 and not the 18, right? That's probably what some of you are saying. Other than I'm just a pure genius. No. Here's how you know. Smallest side always matches up with smallest side. Okay? Biggest side always matches up with biggest side. All right, everyone good? That's how I knew how to match it up. Now this is on you guys. How do I know these 2 fractions are equal? How can you check, maybe using a calculator, if these 2 are actually in the same ratio? Any idea? There's actually 2 ways to check. Anybody? Good talk. Nothing's really changed in the last 5 weeks. Yes, Abbott?
Divide them.
Okay, go out, everyone. You grab a calc and you're like, hey, 10 over 15, 10 divided by 15, that's 0.6666. And then 12, what was it, 12 over 18? I think we got a winner. Okay, I think we got a winner. Anybody know another sneaky way of seeing if they're equal or not? Cross multiply, and you get the same result. 12 times 15 is the same as 10 times 18. That's also how you can check if two fractions are the same. Oh, wow. I learned something today. Impress your friends at the cafeteria table. I'm sure they'll be mesmerized. So that's side angle side. The sides have to be in the same ratio. And see how you match them up? Small to small, big to big. All good? All right, so explain why. I don't need a proof here, but let's explain why these triangles are similar. Explain to me why angle is not going to work here. One, Anna, why wouldn't angle work here? Our first way.
Because it's a right triangle. And
What's AA? Angle, right?
Angle.
How many angles do I have?
One.
One pair. I don't have the second pair. So that's why angle won't work. But let's see if side would work. I have the right angles. They're equal. Now I just have to check. Is 8 over, what's the 8 match up with? We got to start writing these correctly. 10, what's the 8 match up with? 6. Is 8 over 6 the same ratio as 4 over, and notice why I picked 4 here first. Anybody know why I picked 4 and not 3 first? Because I picked 8 first here. All right, I got to make sure the sides of the triangles are from the same one. So 4 over 3, you either divide or cross multiply like I showed you. Do they work? Yep, check. And it says write a similarity statement. So somebody give me triangle so-and-so similar to triangle so-and-so right now. Match them up for me. Name that similarity statement. 3? Nope. How about 6? Give me a good similarity statement.
Triangle BAC.
Yeah, go ahead.
It's similar to triangle EDF.
Yep. And we're going to write by, and this is important. This is why I'm going to have you write it. By. I can't have you write that, though. Take a look. I can't have you just write side angle side because that's for what? Congruent triangles. This is for similar triangles. So what we write at the end is side angle side with the tilde. All right? With the tilde. Side angle side similar. Because if I just write side angle side, we only use that for congruent. Angle. All good. Side angle side. All good. Final method, another one that looks familiar. Side. Side. But all 3 sides have to be in the same ratio. How do I match them up again? What did I just tell you for side angle side? How do you match them up? Smallest with smallest. Biggest with biggest. So why are these 2 sides, or why are these 2 triangles similar? All right, give me a proportion here. Name 2 sides that match up. 7, let's roll. Name 2 sides that match up. Come on, Kira.
13 and 26.
13 and 26. How did she know that? They're the 2 biggest sides. Name another pair that match up. 12, another pair. 5 and 10. So that would leave 8 and 16. Here's the thing I got to make sure I get through to you guys. All 3 need to be in the same ratio. If 2 are and the other one isn't, no, it's not side. All 3 have to be in the same ratio. And as you check on your calculator, they all come out to be 0.5, 0.5, 0.5. So yes, they all are similar. All right. And just something to keep in the back of your mind. It's not used too much, but just to remember, I put it in nice bold there. If you can prove 2 triangles congruent, they're also similar. Okay, so if you can prove 2 triangles congruent, let's say by side, then those triangles are similar too. So if 2 triangles are congruent, they're also similar. All good before we put you to the test. Charlie, you ready to roll? Darn right. Have a nice break. That's good to hear. Good to hear. Everyone else? Okay, sorry, I didn't want you to feel left out. devastated this time. The last 5 weeks, I was like, oh, I should be with my period 1 group. So devastated. Yeah. Ready? As you can tell. Are they similar or not? If they are, you better give me one of the 3 reasons. Okay, so let's look at number 1. Are those 2 triangles similar? If they are, you better give me one of the 3 reasons. Back yourself up. I'm not looking for a proof here. It's not proofs, that's tomorrow. I already have A congruent to R. Anything else you know is true? 4? Anything else true?
The vertical angles.
Yes, they are. AXB and QXR. All right, so the verts are equal. Are these triangles similar? 7
Yes.
by?
A.
There you go. Not bad, huh? So let's write a similarity statement for me. Triangle. Make sure your angles match up when you tell me this. 6. Nice similar statement.
Triangle ABS is similar to triangle RQX.
Nice job matching them up. By? Kara, what was the method?
A.
Good. Everyone's all right? All right, what about 2? Ooh, 2 could be 2 possible methods, right? I could try side, 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 or I could try side, angle, side. Either way, though, I need some sides to match up. They need to be in the same ratio. All right, so give me 2 sides that are that match up that I can test here. 13, 2 sides that match up.
20 over 15.
Okay, 20 over 15. Is that in the same ratio as? Give me another pair that match up. 4. Now remember, I went 20 first over 15, so I got to go with bigger triangle now.
12 and 9.
12 over 9. Let's see. Are they in the same ratio? Remember, you can either cross multiply or you can divide them both and see if they come out to be the same decimal or fraction. What are you guys finding? Are they in the same ratio? Yes, no? They are? What's 15 times 12? Probably 180. Nope. Okay, so that's good. You could even test the third side and it would still work. So yes, triangle. Need somebody's help though. 5, triangle.
PMX.
PM. Remember, you can name it any way you want. Have it right.
Yes.
Similar to
LWA.
LWA. How do you do? Well, if you went P first, P's the right angle, right?
AWL.
What? Whoa. Relax. Ready? This is an icicle. This is geometry now. Your wheelhouse. You see how you gave me P first?
Yeah.
That's the right angle, so I should get the other right angle first, right? W. Now, what would M be congruent to?
L.
L and then? Yep, A. Thank you. Good. And then by, what's the method we used here? We could have used 2. We only used the 1, though. 6, what method did we use? I only matched 2 of them up, though, Nate. Maybe you might have, if you matched all 3 of them. That would still be fine. But the way we did it, see, I only matched 2 of them up with the angle in between. So side, angle, side. Okay? Actually, we didn't use it. I probably could have used side, 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 too. Either one would have worked. All right, ready for 3? Definitely not side, 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 right? Because I don't know anything about the third side. What's the only possible method it could be out of the 3? There's only one choice here. It possibly could be if it is. 5?
Side.
Yeah, because you have the verticals. I'm not saying it is. That's the one possibility. It can't be angle because I don't know the other angle. And it can't be side, side, side because I don't know the third sides. So we need to test. All right, name me 2 sides that match up. 12, 2 sides that match up.
8 and 4.
8 over 4, yep, the 2 bigger ones. Is that in the same ratio as 4 over 3? What do we see here? Yes or no here? Are these in the same ratio? Nope. So guess what? Not similar. Okay, not similar. So we okay on the three methods? All good? Anything? Because I'm going to take it a step further now. If we know the triangles are similar, you guys set up your own ratios now. All right. Here we go. All right, two similar triangles up there by angle, right? Two similar triangles. Which proportion could be used to solve for x now? Basically, match up the sides. All right, that's what they're doing. So let me go step one by one here because this is where it gets a little confusing. So they're saying which one could be used to solve for x. So I'm going to go x over 24. Ready? So see how they took two sides from the same triangle. What does x match up with in the second triangle with? What does side x match up with in the second triangle? Make sure the angles are on top of each other. X would match up with what? 4? 15, but what did they write? 9. See how this proportion is wrong? Because they're saying the x matched up with 9, but it should have matched up with 15. All good? Are we okay on why x number 1 is not a correct proportion? Yes, because they're matching up the wrong sides. Let's go to 2. Now they're doing 24 to 9. Do those sides match up? 24 and 9? All right, so far we're okay. But what's the problem here? Why can I not put 15 here? I put 24 here, Kelsey.
Because you're starting with the other triangle.
I got to put something from the same triangle then. Is 15 from the same triangle as 24? No. Basically, these got to be flipped if I want it to be correct. Everyone all right? So there's a couple ways you could write a proportion. You can start with a side, then match it up with the side it corresponds with. Or you could start with a side and another side from the triangle and then match them up. There's different ways to write a correct proportion, and that's what this is trying to show you. So 2 is out. All right, let's keep going. 32 over x. 30. Okay, so they're putting two sides on the same triangle. What's 32 match up with in the second triangle? 32 and? That's correct. And what's x match up with in the second triangle? Okay, so that looks like it's a good proportion. Why doesn't 4 work then? I know it's wrong, but why? 32 over 12, 15 over x. What's the issue here? Why wouldn't that work? Why isn't that a good proportion here? 3 expense you just got here. Save you. You owe me the notes tomorrow. Good? Okay. 2. Right, Nate? Does 32 and 12 match up?
Yes.
Okay. But what's the problem here? Why can't I have 15 here? What's across from it right now? 32.
Yeah.
Are these from the same triangle?
No.
Okay. So I should have put a side from the same triangle as 32. We all good? You ready to write your own? Ready to write your own proportion? Of course. That's not what I needed right now. That's one thing I did not miss, let me tell you. Is that bad boy. 2 again. Nate, what's the other side?
X.
The one I'm trying to find. Now use your similarity statement to figure out what x matches up with. ML matches up with this side, which has a length of blank. What's x match up with? The side that has a length of 1? Yeah.
30.
ML matches up with RQ, which is 30. Everyone all right on how I just built that? All good? All right. We did these all yesterday now. Cross multiply and let's roll. What'd you get? Excuse me, what'd you get for X? 5, what'd you get?
10.
10, yep. Are you sure you're okay on how I knew 7 matched up with 21? I used the statements to match them up. And that's what I would like you to use if you don't know which one's the shortest, longest. All right, another one here. I think that we'll finish up on this one. We won't get to the last one. All right, sides of a triangle, 7, 4, 9. Similar triangle. So the two triangles are similar. The longest side is 36. Wherever you want to put the 36, it doesn't matter, but it's the longest side. The longest side. What's the shortest side of this triangle? Try to set up your own proportion right now. I don't want to hold your hand here. Try to set up your own proportion to solve. And remember, 36 is the longest side. X is the shortest side. Nobody should be using 7 in your proportion, hopefully. You do not need 7 in your proportion. I'm just doing this to prove a point. I had you guys do it on your own. Instead of us doing it together, I want to prove this point. I'm going to do this. X over 4 equals 36 over 9. Oh, I didn't have that. Who cares? Did you cross multiply 9 and X and 4 and 36? Because if you did, you got a correct proportion. Do you see proportions can look different depending on how you match up and write them? All right, as long as you cross multiply 9 and X, 4 and 36, it's correct. Okay, even if it looks different than mine. Is that decimal one or no? No, it's 16. Yeah, I didn't know 9 into 54. All right, questions? All right, I'm not going to be able to get to that last part, but that's fine. Go ahead, flip your paper over and see what you can do here.
So, let's see.
Everyone see 2 triangles in that diagram? Might help to draw them out so you can see which sides match up to see which proportions are equal to each other. Okay, so sometimes when you have a triangle inside a triangle, it might help to draw them out so you can see the sides that match up. And make sure you match up full sides only. Full sides only. CE and BD should not be in your proportions because they're not full sides. Draw them out if it helps so you can see what sides match up. All right, we'll talk tomorrow.